All right, we're going to talk just really quick about the information on the top of page 5, even and odd functions. Let's start with even functions, and I got a kind of a nice little visual of this information I thought I'd share with you, but I didn't want to claim it as my own. It comes from this website. If you want to take another look at it, they have a lot of good information. It's a Math is Fun website. https://www.mathisfun.com. This is in the algebra section, functions, and it's talking about odd and even. All right. So, just so happens, that is also your next section, odd function, even function. So, really quick, an even function is very simply this. It is a function that if you were to reflect it over the y-axis. So it's saying this tool right here says the output of the function is the same as if you were to reflect the function's output when you plug in a negative x. What that means is that my function is the same as a reflection. Look, I'm going to show you. Plugging in a negative 1, but this would be like plugging in a negative 1 would be that. So this indication, this notation right here means to reflect over the y-axis. In other words, there's a symmetry about the y-axis, like a reflection. All right, and you can see that if I folded this on the y-axis, it would actually overlap itself. All right, this curve right here is x squared plus 1. Look, we changed the k value and brought it up 1. And if I was to fold that over the y-axis, it would work. For the most part, all right, for the most part, it's called even functions. And I'll draw down here, look, x squared, we'll say f of x equals x squared. Kind of looks like that with a reflection mapping it onto the left and right side together. If I did the same thing with x to the 4th, it would look the same. It would be a little skinnier, but it would look very similar. X to the 6th would be the same. This is obviously f of x equals x to the 4th and x to the 6th. So if you look at these numbers, you can kind of tell why they're called even functions. All right, and not all function, just because it's x squared, x to the 4th, x to the 6th, doesn't mean that it's an even function, because if I did this, and I'll show you, f of x equals, in parentheses, what if I changed that x value, or the h value, and scooted it over, in that case, 4 to the right? 1, 2, 3, 4. Well, this would look like that, and obviously it's not a reflection over this axis right here. All right. That said, even though it's in general even functions, there are some other functions that work. This function, and we'll deal with it in a few months, is a cosine function, and you can see that this cosine function, if I fold it along this map, it would look like this, but you can see the sides. This peak would match that peak. If I fold it on the y-axis, this would match that. This would flip over and match this right here. So there are other functions. Now, enough with even functions. Odd functions. Let's start with that notation. It is odd when the opposite of the output, right there, is equal to when I plug in the opposite of the input for all values of x. Well, in general, this is a reflection of the y-axis, and this is a reflection right here of the final number over the x-axis. All right, so basically it's this. All right, it's when a reflection of the y-axis matches a reflection over the x-axis. Or you could say reflect one of them over the x and y, and it'll match to the other one. All right, so let me show you down here. If I look at this, if I reflect this over the x-axis, it goes to here, or y-axis, and if I reflect this over the x-axis, it comes to here. Look, this point right here, reflected, all right, over the y-axis goes to here, and then reflected again over the x-axis goes to here. So when two reflections take place, it matches up. All right, so again, this usually happens. So a linear function, a cubic function, right? I'm going to say cubic function. These functions that I'm writing right now all have very similar properties. And notice the exponents. They're all odd, right? Which is why it's called an odd function. But once again, this sine function, not the cosine function, the sine function happens to be an odd function. So it happens in other situations other than just odd functions. All right. So there's a brief. Your notes are over here, right here. These are the notes given you. Much shorter than what I just put down there. All right. An odd function, all right, here it is. It's when the reflection over the x is equal to reflection over the y. Or you could say it's a reflection across both axes yield the same graph. All right. Even function is just a reflection over y-axis. And sometimes there's not. So they're saying, hey, is this function even, odd, or neither? All right. So we can test this algebraically or graphically. And let's go ahead and do that. This function right here, if I was to graph it, would look very similar to this. And we can already tell that that's going to be an even function, right? This point reflected over the y would match this point. Here's another way to do it. We could say, hey, does f of the negative x, which would equal this, 5 negative x squared, right? Is that going to give me the same result? And I'm drawing that right from here as f of x equals 5x squared. Well, negative x squared, I'm sorry, negative x quantity squared, right, is actually x squared. This actually gives me 5x squared, and this gives me 5x squared. So they are in fact equal to each other. I could say f of negative x is equal to f of x. So this would be an even function. Let's come over here. All right. I could show this graphically. All right. This graphically would look 1, 2, 3, 4, 5 right here. And there it is. And it's quite obvious that it's not even. And it's also quite obvious that it's, you know what, this is not an odd function. For one, this point right here, if I reflected it over the x-axis, it would stay where it's at. And if I reflected it over the y, it would come over here. And it matches no other part of this function. All right. That said, let's go ahead and test it algebraically using this. So I'm going to come over here, and I'm going to graph that. So I'm going to plug it in as this. So if I was going to test the negative of the output of the function, it would look like this. The negative, and this entire thing is the output of the function, so it's 3x plus 5. So the negative of the output of the function is equal to negative 3x minus 5. Well, let's circle that, and we'll see if it's the same as the function when I plug in a negative x. So a function of negative x, now we're only making the x a negative, is equal to 3 times negative x plus 5, which only gives me this, the function of negative x. It only gives me a negative 3x plus 5. So quite obviously, this is negative 3x minus 5, and this is negative 3x plus 5. All right. So I'm going to highlight this last one. This is really something, especially the inputting of these different values, especially the opposite of the entire function, right, which is this up here, and the opposite of the function when you put in a negative x, just the notation, making this normal in your head, making this natural. So I'm going to end this. I realize there's not a whole lot, but it's only going to take one more video to cover all of the rest. The rest of this stuff's going to go pretty quick. But try 3 and try to really look at and understand this section right here. And I'll talk to you guys soon.